Imagine opening up your notebook after a completely exhausting experiment. You look down and, wow, it's just a giant puzzle of random numbers, scribbles, and hasty notes. Basically, pure chaos, right? When you're looking at raw data in this state, it is virtually impossible to figure out what it actually means. And that brings us to a really interesting guiding principle from our source material today: write the vision, make it plain. Think about it. If your experiment reveals a totally new truth, but you leave it in that chaotic state, no one else is going to see it. So turning that crazy chaos into absolute clarity, that's our ultimate goal today. So, welcome to today's Explainer. We're going to dive right into mastering the art of scientific data organization. Whether you're in a lab or just trying to solve a real-world problem, structuring your data is an incredibly powerful tool. Let's see how the source material suggests we make those random numbers actually speak clearly to us. Here's our roadmap for the Explainer. We'll start with from chaos to clarity, then mastering data tables, choosing the right chart, record data right now, and finally, education, morality, and peace.
Okay, let's dive into this first part, from chaos to clarity.
So when you're out there collecting information in the field or the lab, raw data is, well, almost always super messy. It's this wild mix of numbers, random observations, and completely unstructured notes. And the big issue here? Without structure, the patterns are just invisible. The truth is literally hidden inside that mess, which makes it totally impossible to analyze or actually communicate your findings. Which brings us to the core definition of organization here. It's all about structuring information so you can analyze it efficiently and communicate it clearly. And the material really emphasizes something absolutely crucial. This isn't just some strict lab requirement. It's a foundational, lifelong skill for engineering, business, and honestly, just making smart personal decisions every single day. Moving right along to Section 2, Mastering Data Tables. To capture data correctly right out of the gate, the text outlines what it calls the anatomy of a perfect data table, using 3 totally non-negotiable steps. First step, write a descriptive title. Second, label all your columns and rows. And third, and this is a real game changer, include units for all measured quantities. Because think about it, without units, a number like 10 could mean 10 seconds, 10 degrees, or 10 centimeters. We absolutely need to know. And this brilliantly illustrates those rules in action with a classic ramp experiment. We're testing how the ramp angle actually affects travel time. Notice how the labels are crystal clear, and the units are right there, degrees for the angle and a little s for seconds in our trials. Because the data is neatly structured into 3 distinct trials, it's super easy to just cleanly and quickly calculate the average time. All right, Section 3, choosing the right charts. Once all that data is actually recorded, we need to transition our tools. Data tables, you see, are perfectly designed for entering those raw measurements neatly while you're doing the actual work. Charts, on the other hand, they're your presentation tool. While the tables hold all the raw facts, charts are what we use to rapidly summarize, compare, and quickly share those findings with the world. Of course, choosing the right visual completely depends on the data you have. Line charts are absolutely ideal for showing changes over time, like if you were tracking a plant's growth rate week by week. Pie charts are what you'd use to display proportions of a whole. And bar charts? Well, they are the absolute perfect choice when you need to compare different categories. Now, what's really interesting about this example is how, looking at a survey of favorite science topics, a bar chart just instantly communicates the results. With the topics categorized on one axis and the number of students on the other, you can literally see the most and least popular subjects in a fraction of a second. It really is that fast. Moving into Section 4, record data right now. Now, our source material stresses a really critical behavioral habit for anyone doing this kind of work. You have to record data exactly as it's collected, not later. The cost of waiting is just way too high. I mean, relying on your memory for even 10 minutes practically invites mistakes. Important details like maybe a slight temperature change or a weird sound during the experiment, they're so easily forgotten, which leaves huge gaps in your records. True organization requires immediate action, no waiting around. And finally, Section 5, education, morality, and peace. Now, the Explainer source material, which comes from the heroesmartacademy series, connects this whole discipline of finding the truth to a much broader philosophy. It states quite simply, education without morality will hurt. The argument here is that organizing data and uncovering the facts, well, that's really only half the battle. It is equally important how we choose to act upon that truth once we find it. The text then points to another guiding principle, referencing Romans 8:6-7, which suggests that keeping one's mind spiritual actually brings peace. The source argues that when you take the highly structured thinking you learn in science and you combine it with a strong moral and spiritual focus, those two things align to bring true clarity and genuine peace of mind. So the material leaves us with this final, really provocative thought to chew on. What is the point of knowing how to build perfect data tables and brilliant charts if those skills aren't paired with good choices? The ultimate takeaway here is to use the clarity you gain from organizing data not just to ace a lab report, but to inform smart, moral decisions in the broader world around you.